Hello, in this video I'm going to discuss the Arclength formula, S, and that is the letter S, equals theta R, where theta is an angle measured in radians, and it can only be used with radians, and R is the radius of a circle. Now I want to kind of go back to, I want to see why that formula is what it is, S equals theta R. So I want to go back to the definition of the radian. The radian is the rotation needed to generate or subtend an arc length of one radius for any given circle, regardless of the size of the circle. So again, the idea is if I have a piece of string here that is the size of the radius, right? And then I take that and I wrap it around the circle a little bit, starting at 0, for example. If I wrap it around, this rotation, right, the rotation that's from here to here, so that means this movement is 1 radian, and then of course that corresponds to the arc length. The arc length is right here. Right? That is S, an arc length of 1 radius. So that definition is incredible. We talked about it before because it connects a length and a rotation. Right? So a radian is a rotation, an arc length is a length, a distance. Okay, and just to remind you here, 1 radian generates different sized arc lengths depending on the size of the circle. So obviously a smaller circle has a smaller radius. So even though when I sweep out or rotate 1 radius, I have a smaller arc length than the arc length on this outermost circle. Right? So let's take an example. And just look at, for example, suppose we have a circle, and that circle is a radius of 5 feet. Then we can see, let me see if I can draw this here. Here's a circle, right? And let's say we have the Cartesian coordinate system there. And we say, okay, let's go out 1 radian on this circle where the radius is 5 feet. Well, so that's going to be about here, right? Something like that. But we know that the arc length, since we went 1 radian, then the arc length is 1 radius, which in this case is 5 feet, right? Now, if I go ahead and do this again and sweep out another radian, right, somewhere around in here, then the arc length that I'm going to generate is another 5 feet, right, for a total of 10 feet. So right now, when I rotated 1 radian, since my radius was 5 feet, the arc length was 5 feet. Here, I got 10 feet. When I go out 3 radians, which is almost here, right, I have another 5 feet, so for a total of 5, 10, 15 feet. And if we keep doing this, what we're going to find is that if you multiply theta, the radian, times the radius, right, you get the arc length. Okay. When you do 2 times 5 here, you get 10, 3 times 5, 15, and then we go to 4 radians, for example, maybe here, that's another 5 feet, and of course, what you'll see is you have 20 feet, so 4 sets of 5 feet, okay? So in general, as long as your as long as your angle is in radians, if you multiply the angle rotation in radians times the radius of the circle, you'll get the arc length that's generated, okay? Now, hopefully you could see why the angle has to be in radians. I mean, it really comes, of course, from the definition, but I mean, think of if you tried to do this in terms of degrees. I'm even going to be exaggerating by doing this, right? If I say that's a degree, which is already too big, but I couldn't write it any smaller. Obviously, that has no bit, I mean, what's the relationship between that and the radius? Don't know, right? Whereas 1 radian is defined to be the arc length for 1 radius. So you must only use this formula in radians. Okay. So now let's talk about when do you use S equals theta R? Well, you use it when the path of an object or a person that you're tracking is curved along a circle. All right, so it sweeps and it's like at the tip and it's kind of tracing out a circle. So that's one way. The other way is when you use arc length to approximate the length of a chord in a circle. So 2 conditions there have to be met. So I should put here in a circle, right? So to be able to approximate, you have to have two conditions that are met. The circle must be large and the central angle must be small, less than 10 degrees. And this can be vice versa. A chord can approximate a arc length. So we're going to look at videos. I'm going to have a video on these kind of problems where it's the path of an object that is curved along a circle, and then I'm going to have some word problems that are where you use arc length to approximate the chord. Okay, but let me just kind of show you what that might look like. Let's take a look here. So you might have, for example, in this problem that we're going to look at, they talk about nautical miles, and you want to know what's the distance here along the Earth, which is not quite a sphere, but we can approximate it using a sphere. So that's like a curved path that you're trying to find the distance of. All right, so that's one way you'd use arc length. Here's another example where you'd use arc length. You have a chain link that is going around 2 gears for a bicycle, and what happens is they both have the same arc length, because otherwise if they didn't, one couldn't keep up with the other and it would slip. So basically you're going to use arc length for this. Okay. Whereas for something like number 2, there was a video approximating the diameter of the sun. That was one. Another would be, for example, here where you have, let's say, a tank that's really far away. Let me take it that other way. Tank that's really far away, and you're looking at it, and it subtends an angle that's very, very small, and it's part of a huge circle, like this. And the tank itself is vertical, it's the chord, but basically this little piece of the circle is the arc length, and it's very close to the size, to the length of the chord. And so as long as you have a big circle and a very small central angle, you can say, well, this length here, the arc length, is very close to the length of that chord, and so I can go ahead and use it for that. So that's when you use this formula. And by the way, you can go the other way around on the approximation. We talked about how an arc length can approximate a chord, but sometimes you'll want a chord to use a chord to use to approximate an arc length. That'll work too. Thanks so much for listening.